Hello, and welcome to our second lecture on metabolism, where we discuss redox reactions, specifically oxidation and reduction reactions. This is where we're going to be talking about electrons and how they are going to be lost and gained, and it's going to be kind of like a mirrored relationship. If one gets lost, the other is gained. One is reduced, one is oxidized. Kind of like a if and or a black and white kind of mind of thinking. Okay, so it can get really uh, difficult to imagine, but easy to kind of put into place once you get the right idea going. So when we talk about a redox reaction, we're talking about two different reactions. Like I said, they're mirrored, they're flip-flopped, they're the reverse of each other. They are reduction and oxidation. So if electrons are going to be lost, shared, gained um, in any kind of chemical reaction, that would be called a redox reaction. Okay, and it happens according to their redox potential. Okay, so redox potential would just mean, hey, you have a stronger redox potential than I do. Let's transfer our electrons toward you. Okay, because of that, it's going to occur kind of naturally um, based on that potential. Okay, that's kind of a lofty term, though, redox potential. At the end of the day, the main thing that we need to know is that in an oxidation reaction, you are going to lose electrons. Okay, oxidation is the loss of electrons. In reduction, you are going to gain electrons. Okay, so if you imagined that if you gained electrons, they didn't come from nothing, they came from somewhere. So that means if you had gained them and gotten reduced, I'm now reduced with those electrons in my hands, then whoever gave them to me is going to have been oxidized. Okay, so um, you can't have one without the other. Okay, so an oxidation is gaining those electrons, and oxidation is losing those electrons, and reduction is gaining those electrons. Okay, and then here we have two nice kind of graphs to kind of illustrate that. Okay, so in this first picture, we have two compounds. Okay, we're going to start with two compounds, and one of them has a higher redox potential than the other, so they're going to lose electrons. The reducing agent here is going to lose its electrons. They're going to come over to here. Okay, and now that these have the this has the electrons, it is now reduced. This one no longer has the electrons, it is now oxidized. Okay, note these terms here. Okay, they're the reduced and oxidized compounds. You can just kind of leave it at that. The A and B kind of make it a little bit more difficult, but just kind of say on the product end, they are the reduced and oxidized compounds. On the reagent end, we are going with that name in the parentheses, the reducing agent and the oxidizing agent. And note that if you start out as the reducing agent, you are going to become the oxidized compound. And that's by definition. Okay, so there's no other way around that. If you gave away your electrons, you are going to now have lost those. You become oxidized. Okay, the person getting those electrons will have gained them and they become reduced, but they had started out as an oxidizing agent because they caused the other reagent to become oxidized. Okay, so it's a big flip-flop. Okay, if you are the reducing agent, you become oxidized and you reduce the other compound. Okay, if you're the oxidizing agent, you become reduced and you oxidize the other compound. Okay, So, like I said, the potential energy is what powers these, okay? And most of the time in our cells, we have three different electron carriers that are solely to carry these electrons safely, okay? And we call them um, coenzymes, but here you can see that they are just in this form electron carriers, okay? And if you look, that they have both the oxidized form on the left, okay, and then the reduced form on the right. Okay, how do I know that? Just by looking at it. Okay, there's a trick. The trick is that if it has a hydrogen in the name or in the symbol, it's going to be reduced. It'll be the reduced compound. Okay, this hydrogen here, this H, and then this H over here, and then that H right here. Okay, that tells me that it is reduced. Okay. Now, how did I work that out mentally? Well, if I had gained an electron, I was reduced, right? Now I'm reduced, so I had gained an electron. An electron is negatively charged. That negatively charged is attracted to this positively charged molecule right here, okay? So with that positive charge, that electron is going to rush to it, okay? And that rushing to that positive charge is going to cause it to become a hydrogen molecule, because a hydrogen molecule is just, apologies with my fingers, is just a proton and an electron, okay? NAD also has that positive charge, all right, and it gets reduced with the hydrogen. And FAD does not have that handy-dandy positive charge, but it has two hydrogens, okay? So those two hydrogens are going to hammer it home to you that those two hydrogens got it reduced, okay? It is reduced even though it didn't start out with the positive charge, okay? But either remember that if you have a positive charge, you are going to attract an electron. If you attract an electron, you are going to gain an electron. If you gained an electron, you are reduced, okay? So that's one way to work it out, or you can just look for where the hydrogens are, okay? And if you can choose either one, okay? So in this example, we have which compound is being reduced in the reaction above, okay? So first of all, let's look at these questions. Redox questions always have what seems to be a very confusing question, okay? And it's not meant to be, it's just how can we ask it and it still mean the same thing. Sometimes you're asking it and you don't know. Okay, what's 6 plus 7 or what's 7 plus 6? It'll be the same answer, but it's a different question, and sometimes it comes up differently in conversation. So, in this regard, which compound is being reduced in the reaction above? Okay, so if we're going to say which one is being reduced, we're going to say which one is going to end up reduced. Okay, which molecule will end up reduced, not which molecule is reduced. Okay, so what is the reduced compound is different than what is being reduced, right? Okay, so now that we know the question, what is going to end up reduced in this reaction, all right, we're going to say, okay, well, what got reduced, okay? So if this got reduced because of my hydrogen trick, then it is reduced, okay? Then that means this is going to be reduced, okay? And I apologize for this. That says reduced, but it was illegible. So NAD ion or plus is our answer here. Okay, it is going to be reduced in the reaction above. Okay, so note that there's a couple other questions we could ask here. Which is the oxidized compound, right? The oxidized compound would be here, oxidized compound. How do I know that so easily? Again, because this is the reduced compound, this has to be the oxidized compound, okay? Because it's just a flip-flop, okay? So keep testing yourself that. This is where the worksheet is, okay? I will try and record the worksheet at some point, me filling it out, me finding it. But note that we have some uh, reactions that you want to work out with, okay? And redox reactions, you need to have that, okay? Um, but before we go, I want to bring you back to my page. I have these pages on Canvas, remember? These ones are more curated toward a student rather than like a lecture. Okay, these are kind of like talking to you sometimes in a very conversational way. So you see, we kind of go over redox again. You can kind of see the reduction of gaining an electron with the plus and the losing of the electron. Okay. And then how can I remember this? There's a mnemonic with Leo the lion goes grr. There's oil rig. There's Redox, making sure you have Redox on each side. Please, please, please don't fall behind in redox reactions. What we're going to learn about in the electron transport chain is literally dependent upon redox reactions. Okay, so come back to this lecture twice or more if you need it. Okay, redox reactions are going to be pivotal. Okay, and if you have a redox on one side, you have a reducing agent and a oxidizing agent on one side, and you're going to have a redox on the other side, a reduced compound and an oxidized compound on the other side. They're going to flip, okay? The reduced compound won't be the reducing agent, and the oxidizing agent won't be the oxidized compound, right? It just won't do that. All right, so keep that in mind. Message me if you need any help with these, and we'll end the video here. And we'll keep it going with enzymes in the next video.